Okay, subsets. Let's get started. Oh, by the way, if you're wondering why I'm wearing a jacket in my apartment, that is because it's freezing cold now in Seattle, which is not what I expected. And most apartments don't have AC. But more importantly, I can't afford turning up the heat right now because I'm broke. So if you'd like to donate, please check out my Patreon, and thank you for your donation and support. Let's get started. Ah, man. Life is tough, man. Life is tough. Alright, given a set of distinct integers, nums return all possible subsets, the power set, whatever that means. The solution set must not contain duplicate subsets. Okay, so we have 1, 2, 3. So the concept of subset is very straightforward, right? Just it's a set that contains elements that is from the superset. So you have 3, 1, 2, 1, 2, 3, 1, 3, 2, 3, 1, 2. So it does not contain duplicate subsets. So you don't see 1, 3, 2 here. So very straightforward. And the explanation is pretty clear. Even if you don't understand the concept of subsets, you still get the idea from reading the example. So this is a very typical depth search, or should we say breadth search problem. Right now, if we usually I would prefer a breadth search. So a breadth search of the breadth search approach for this problem would be, so you assume that we start from an empty set, right? We assume, so we forget that we are doing, let's say we forget we are doing AB 1 through 3 right here. We forget we're doing 1 through 3, and then let's assume that we start from an empty set, and we're just exploring. We're exploring what kind of combinations of subsets that we can have if we add one more letter. So we start from empty set. Now, of course, the subset of an empty set is 1, right? Which is included here, right? And now we add a number. So this set right now has a number or element. Let's say I call it an element, right? So let's explore what options we have if we add elements to the set, right? So now we have empty, and then we have this element, right? Let's call it A. And then let's explore what other options that we have if we add another element to the set. So let's say B, if we add B, right? So it's gonna do in breadth search, but the starting point is this newly added element. Wow, let's say B at this point. So for B right now, what are the options that we have? We have an empty, set, and also we have a set that only contains A. So also we'll explore these two options and append B to it. So we have empty set, and a set with AB, and then we have A, and then we have B, right? So it's that is a very simple idea. I think we can go ahead with the breadth search implementation, and then if we have time, we'll go back to depth search. All right, so now we'll start coding. I have to put on my glasses. Okay, so now first of all, you need a list of lists to. So what variables do we need? So first of all, we need a list of lists to store the results, right? Because the return type is this, and then we will need a temporary linked list to go through the results, which is this one, so that we can add this temporary list to the results. So these two are the variables right now I can think of for now. So for now, also do list list integer. Well, call it results and equal to new linked. Well, let's call it linked list. Okay, and we'll call. Well, actually, yes, linked list is fine. And for this temporarily, temporarily, this word is so hard for me to pronounce. Temporary, right? Temporary, right? So this temporary list, you gotta do new array list. Okay, well, because actually, why would you even need array list to just do list? Because you're gonna keep adding. You're not going to access. At least for me, what I'm thinking right now is, I'm just gonna keep adding new elements to either to the results or to the temporary list. So I don't actually need to access random elements. So this linked list would be doing this with linked list implementation would be faster. Okay, so now we need to add the starting point, right? The starting point, which is the empty set. And then now we can, again, based off of this point, now we have a starting point. It's time for us to start doing an induction, right? So which is this for loop. So for I is equal to 0, I less than nums.length, and then I plus plus. Okay, so first of all, what we need to do here is to, well, first we're exploring the option, right? So we will first of all we'll save this character so that for later use, right? So right, this is integer, so only has integers. Okay, all right. So this one we only have integer, and so let's say number is equal to nums I. Okay, so now we will first of all we'll check out what options that we currently have, which is what we already have in the result, right? So first of all, we'll get, it's like a breadth-first search. The result right now, it's kind of like a queue that we usually use for breadth-first search. So first of all, we'll need to save the current result size, right? And result size will be just result size, okay? And so, and then we'll need to do a j is equal to 0, and then j less than current result size, and then j plus plus. Okay, so for every, well, now I think that we should do an array list because I'm accessing every single. So my bad. So result here should be a array list, because that will allow us to have faster access. Checking the time. Okay, I'll make sure that I finish this in 15 minutes so that I get time for another implementation. So Okay, now we are currently iterating this. So first of all, let's get integer list. Let's call it temp, right? Is equal to result get what? Get this. We're getting this node, right? Okay, so we're getting this node. So we're getting this node, and then we need to have a new copy of this, right? Or else like we'll lose this current node after we add a new element, right? So first of all, the most important thing is that because this is reference by address, so we need to create a new list, or else if we do anything to it, it's going to modify that freaking list. So first of all, we'll have same, and then we'll have a new list is equal to new list, well, linked. By the way, I'm wondering, can you initiate as new linked lists? This is called linked list Java 8. Can you initiate a new linked list just putting constructor collections? Constructor list containing element of specific data returned by the iterator. Okay, so we can indeed put the new list into that constructor. So we'll have a linked list, and we'll put this temp into it. I'm sorry, this is not the right thing. Construct. Wait. Sorry. This is the way you construct. That's right. How does the constructor look like again? I just can't remember shit anymore. Okay, that's good. All right, so you put in this temp. All right, so you have a new list, and then you are going to explore this option. So we'll add num new num, and then what you need to do is to put this this new result back to the results. So I mean, put this new let's say node, right? Put this new option back to the result. So the new add result add a new list. Okay, so this is done, and so this is done, and next thing we need to do is, so let's go through this logic again. So for each for every node in the current result, right? We'll get it. We'll pop it first. Okay, so we'll get this node, and so we'll get this node. So the difference between the regular breadth search method is that there's no popping here, but the idea is the same. So you get the list at this current location, right? And then you make a new list to it, add this number, right? Add this number, and add this this new list back. So now right now you have to explore this new. You have it kind of like explore this new route with B. Okay. So after that, you should be able to have a new list size. By new list size, I mean the size of the result. So you will keep. So you keep iterating the elements, and then at the end you'll return the results. Okay. So that's it. Let me see. Okay. So let me run it. It's pretty. The code is not that much, but it's just. Whoo! Let's see. Accept it. Okay, perfect. How much time we have left? Oh, 15 minutes. Oh, perfect. So we have time to do another solution. So, okay, let's comment this out and okay. God damn it. Okay, let's comment this out and do a depth search solution. So, my understanding for breadth search is that you are kind of like trying out different possibilities with known results, right? However, with depth search, you are this is my dinner, by the way, because I can only afford grapes for my dinner. I'm kind of hungry right now. Wow, that's sweet. Alright, so, but in terms of depth search, you're kind of like exploring the unknown. So breadth search is trying out known results, and depth search is exploring unknown. So instead of trying out all the known possibilities, depth search, we should try to reach out to every single character and then go deep inside. Yeah? Go deep inside of the, as deep as you can, right? Of that results, right? So how do we change this code? So first of all, like we said, we need. Let me reuse this code. So we will have to use a result the same as this one, and we will have. Also, this is the same thing. We'll have a list to store the current result, and then we will start doing the depth search, right? So let's say a helper. So first of all, you also of course have to pass in the result, and you have the passing list, and then you will, of course, this is what you need, passing numbers, and then you need to pass in the index so that you know what current position you're at, and then you can based off of that point, you can start exploring different opportunities, right? It's just like when you're dating, right? You want to explore different girlfriends, right? That's wrong. That's not a good idea. Let me warn you. Can't do depth search for dating. Okay. Okay. So now this point, because we start from the beginning and we'll start from the first index, and we have 10 minutes. At the end, we'll return the result. All right. So now we have the helper function. We will need to. So first of all, what's the return type? What I'm thinking right now is that since the result and list are all referenced by address, we don't really for now I think it's safe to do void, and if we need to return anything, we'll do that later. Okay, so helper, and I'm gonna be lazy a little bit here. Result. and list and int nums, and you're gonna use a start index. Let's take a start. Okay, so when we reach this point, first of all, we will we'll add we'll add the current result. First of all, we'll add the current result to the list. So result add list, right? Because at the beginning of the helper function of a depth first search, you usually do the termination step first, right? So eventually you want to terminate it by adding something to the depth first search to this search. So you add the you add the current node to the result. Now it's time to do the exploration of different options, right? So you do for I is equal to start, and then I is less than numbers dot length. And I plus plus. Okay, so now you will add this character, or sorry, I keep thinking it's character. So add is equal to nums I, right? So first of all, you will add this number to the current list. So wait, hold up. If I add this, there's going to be a problem. Because I'm thinking this, because I'm modifying a list here and I'm adding a list here, well, I have a problem. Yes, I will have a problem, right? Because I will have a problem because this is referenced by address. So if I keep doing modification here, it's going to also change the list. God damn it. That was a close call. Wow. Jesus. Okay, so you have a list add num, and then what you should do is go through this helper function. I'm still thinking whether I should do this. Yes, I think I should do this. So helper will put result and list, and then nums. But however, for the start, you will do, because you have already added this number to the list. You will start +1. But don't forget to remove the number that you just added. I'm doing the index, remove index. The remove method also takes in an object, but I don't want to do that because I'm afraid that it's going to reference to the wrong object. So doing index is the safest because that's going to be the last node. All right, so we're done, and then there's nothing else to do. Wow, the code is even shorter than this. Here's the thing with depth first search. The code is shorter, but to comprehend a depth first search problem, the time it takes to comprehend depth first search problem is going to take longer, because it's recursion is not normal human thinking habits. Normal humans normally think of in iteration pattern. All right, because usually human it's like dating, right? Like humans just don't think in deficit way. Like you don't date a girl, get engaged, married, right? Have kids, and then go back, divorce, and then go back, and then I try another girl, get date, right? That's too risky, right? Usually, you do breadth search, right? You date this one, date that one, date this one, date that one, and then oh, found this one is good, then you continue with that one, right? I don't know where I'm going with this. So okay, so I think this is good. I'll just run the code. Wait, I said listed list. Okay, linked list. I have one, two, three, one, three, 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 three. I have three, 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 three. 1, 3, 3. Huh, interesting, interesting. Why do I have 1, 1, 2, 1, 2, 3, 1, 3, and 2? It's impossible. 2, 2. So I have 2, 2. I have 1, 3. Okay, so I have 1, 2, 1, 2, 3. This is right. And then I have 1, 3. And I have 1, 3, 3. I have 1, 3, 3. And if I have 2, I have 2, 2, 3. Interesting, interesting. 1, 1, 2, 3. Should I also check if the current okay, so result dot add. Okay, let me think. Number, add this number, and then we will continue adding this. Okay, 2 minutes. So 1, 2, 3. So the first round is correct. 1, 2, 1, 2, 1, 2, 3, and then we should start iterating 2, right? So, do I have other empty set? Okay, so 1, 1, 2, and then 1, 2, 3. Now this is correct, and then I move back to the third element, which is 1, 3, and then I have 1, 3, 3, which is something that is confusing me. Oh, wait. 1, 3, 3. I have 1, 3, 3. I have 1, 3, 3. So 1, 3. So 1 through 3 is when I got back to. Is that when I got back to 3, right? It's like I reached the end of this deficit because I start from 1 and I reach the end of 1, 2, 3, and I go back to since I remove 2 and 3, and then I go back and I move on to the third element, and then we have 1, 3. Oh, wait. I added 1, 3, but then oh, I added 1, 3. I added 1, 3, and then I continue. Okay, hold up. God damn it, my brain is not thinking right now. 1, 1, 2, 1, 2, 3. So this is empty, right? This is empty. This is empty set. This is the iteration of this empty set because we have start from 0, 0. So we'll have 0, 1, and 1, 2, and 1, 2, 3, and then we are iterating based off of these 2, these 4, and then we have 1, 2, 3. God damn it! Fuck! Yeah, deficit is always why. I haven't written a deficit solution for a while because if you do a deficit search in real life, and when other engineers see you have a deficit search in your code review or your pull request, they're going to leave thousands of comments on that. They're going to ask you to rewrite that. To be honest, I haven't seen a single deficit search in real life. I'd like to figure this out why. There's no way. Okay, so we have this new linked list. All right, this is the current list, and so we add this list first, right? We'll add this empty list first, and then we start from the next. We start from the next element. We start from the next element. So we'll start adding. So 1, 2, 3. So this is 1. Add list to 1. So we have 1, and then helper get into this helper function. So we have 1, and then 1, 2, and then 1, 2, right? And then 1, 2, and then 1, 2, 3. And then 1, 2, 3. Okay, so 1, 2, 3 is the end of that branch of that depth search. We reach the end, and then we'll remove it. Okay, we'll remove it all the way to the back. So we're back to wait. Maybe we should add it here instead of here. Should I add it here? Let me think. If I add it here, then I have to add it at this list here. But does it matter? I feel like it's the same, right? It's the same. If I add it here, it's the same. Wait. What the hell? It's the same, yeah. And I'm missing empty set. But anyways, it's and I have 3, 3, 3. Which means that oh wait, hold up. Wait, so that means that I also need to check. Is there a 1 3 2 3 2 2 2 2 3? So it doesn't go backward. Oh, shoot 3 2 3 2 3 3 3 2 3 2 3 3. This is confusing as fuck. You have 3 3 2 and 3 2 3 and 3 3 and 3 3 3. So for every character, you're adding 3, and then you add 3 2. Oh, shoot. Maybe you shouldn't start from. Maybe you shouldn't start from start. Start plus 1 is correct, right? Start plus 1, and then you remove it. What the heck is wrong with this? Okay, it's 3 2. Okay, it's 3 3 2, and then 3 2 3 3, and then you're at 3. But how come 3 is also going on? I don't understand. If you're 3, it should stop right there, right? And 3 is still going on. It still goes on. Like 3 is still at. You should have stopped right here. And you still continue to count it. This is something that is beyond my comprehension. Huh. Wait. List.add num and remove list.size minus 1, so remove the last one, and list result list nums start plus 1. So why is it adding 2 and 3? I don't want to waste too much time with yours. Restart. I want to figure this out. By the way, when I publish this, should I count it as failed or not failed? Because obviously I succeeded in the first time with buffer search, but then with deficit search, didn't try to. Why? Oh. Okay, so let's see. Okay, let's start from beginning. So 1 2 1 2 3 1 2 3 1 3, and then 1 3 3. 1 3 1 3 3. So this is the end of the first search, and then you remove it, right? So 3, it added 3 because it removed 2. It removed 2 and added 3. it removed 2 and added 3. It removed 2 and added 3, and then we go ahead, say 1, 3, remove, okay, hold on. Remove 2 and added, remove 2 and now it added 3. It added 3, and then we go into this helper function. Should it be I plus 1? Oh, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I plus 1. Why did I put start plus 1? What the okay. I think this time should be great. Accepted. Okay, perfect. All right. Okay. Cool. Did I fail? I would say so, right? I would still say I succeeded, right? You had to be confident, right? This is, as a man, you should be confident. Especially when you approach a girl, right? Just as a software engineer, I feel like the reason why that most software engineers don't get a girlfriend like you right now is because you're not confident. You have to be as confident as me, right? Just do it, right? Just do it. Okay. No, I'm about the same. That's why I'm standing here on a weekend coding in front of the screen instead of going to bar, hitting on girls. No, that's sad. Anyways, so yes, so wow, this is the most important thing. I thought it was what a I put start plus 1 first and cause problems. Caused problems. So remember, I plus 1 being you're exploring the option next to you, right? So I did start plus 1, which is not, it doesn't even make sense. Start plus 1 means that you always explore from the origin, that one element from the origin. And okay, so don't forget about this when you write this. So don't forget, always explore the next option. Okay, so you're exploring the next option, and that's the core of depth of search. Okay, anyways, thanks for your time watching me figuring this out, and I guess I'll see you next time.